Hey guys, welcome back to the channel. I have another Marine ECM, this time working on a MEFI 4 5.0 GXi-E. This coming from Kansas, Thomas Klinkenberg. Klinkenberg, yep, I think I'm saying it right. So he said fuel pump, main issue, fuel pumps non-functioning. All of my wiring is, I'm just gonna keep you there so I can read that for a second. All of my wiring is checking out as good. I have continuity from the ECM to the relay and then a solid 12.5 volts through the three grounds on the J1 and a solid 12.5 volts through the three grounds on the J1. It looks like I would like to ask Thomas what is exactly he's referring as a solid 12 volts through the three grounds. So you're checking with a multimeter. Multimeter can be deceiving, and I'm going to tell you that even if you have one wire strand on that wire, when you're measuring with the multimeter, all the multimeter is putting is like at 3 volts through the wires, so it's very low voltage to actually create the equation and give you the voltage, right? So I always use a test light or a substituted load that you can actually load the wiring while you're doing the test to make sure that it's actually indeed a good ground, because you will see if you ever have a test like that, or you run a test. Give me one second. Well, I can move that later. And when you load the test and you keep your meter there, it goes down to 2 volts. Now it's not enough to light up the light and to keep that ground to show good or voltage, right? So always perform voltage drop test with a load. Without a load, you will have not a conclusive test. All right, so it says 12.5 volts to the three grounds on J1 ECM connecting connection and continuity from the relay to the fuel pumps. I can add power at the relay and turn on the pumps. Okay, so this is another thing that I not understand it properly. I'm probably going to call him right now. He said that he's adding power to the relay and adding pumps. So if you're adding power to the relay and the pumps run, then you're missing a power, because as you see right now, I'm running your computer. The fuel pump relay is on, and I can command it, and I'm going to show you that in a second again, because I got, as you see here, is running. I got zero fault codes, so everything is checked out as good. I don't see nothing wrong with the computer. Reading what you're saying in here that you add power to the relay. Well, the relay should have a constant, you know, power on terminal 30, and then that is the load side. You will have the terminal 87 and goes over to the fuel pumps, or 80, yeah, 87 to not confuse anything. You will have, that is the load side, and the control side, which should be smaller connectors on the relay. You should have pin 85 and pin 86. Pin 85 should come from the computer. And sometimes it's backwards, depends on the manufacturer. So I will have to really see. And actually, let me get a wire diagram. I got a diagram for the fuel pumps, as you see right here. So we got, as I was saying, okay, so we have terminal 30, which is a constant battery power through a 20 amp fuse. And as far as I see from, this is specifically for your boat. This is the original manual that you can actually also find in Diacom. If you have Diacom Rinda software for laptop, I always tell everybody, don't buy the TechMate, because all you're doing is just wasting your money. I mean, it's a good tool for quick diagnosis to see pits, but you lose so much more information that you can gain by having the laptop base, and you can record and do some other things. But talking of Diacom, please watch my videos about Diacom, and then you understand what I'm talking about. All right, going back to here. So we have terminal 30, terminal 87. So the load control by this relay goes from constant power, again from the same fuse and the battery positive, when the relay closes the contact, and then sends the power over to the pumps on terminal 87. Terminal 85, as far as this diagram shows, this has also a constant power through that same fuse. And then on J123, the control, which is a ground side control coming from the computer on terminal 85. And we can see the description of everything that I had just described. I'm trying to make it as, as easy as possible for you guys to understand what the computer did. During key on, the ECM will turn the pump on ground terminal 85 of the pump relay for 2 seconds. I can turn the computer on. Let's watch this right here. So I'm going to turn the RPM off, turn the computer off. Now let's turn it back on. One, two, then goes on. Okay, so it's doing the fuel pump prime and it runs instantly and the fuel pump relay is on. So I don't see anything really wrong with that. Everything is working as it's supposed to. So I have this connected because in order to gain access to those manuals, again, you open your Diacom software, laptop base or PC base, Windows base, right? When you open this software, you can select your computer, and I'm going to do all the connections. So this is the first pop-up again, kind of like on the symbol of the boat on the left corner. You're going to select MEFI 124. You click OK. This is going to read the computer that is connected, and now you're going to select mode 1 is the one I use the most for diagnostics. All right, so that's it. I have also select my own personal preferences as far as speed because these lids on the MEFI 4 it has like over 200 pits, so it's too much, and some of them are not even being used. Depends on the computer. This is a 5.0, so very basic one. All right, so when you're here, now you're ready to connect. If I connect, now I can start seeing the pits and everything. And as you can see, remember I have the zoom glass in here and I can go into trouble codes and I can start selecting pits. So I always happen. Come on. And this is making it. So we got zero trouble codes. It also start without warnings, without malfunctions 250 times, 255 times. So again, also if we have start without warnings, it says 255 times. So not sure where are you having the problem, but definitely it's not in the computer. All right, going back to where I was. Here you can select manuals. When the computer is connected, it says please stop the communication. So that's what I do. You disconnect. Now I can click on that open service manual right here, right? It looks like a book. If when I click in there, I just click Volvo Penta. This will open all this, and now I can select 2001 to 2005, MEFI 3 and MEFI 4 and 4B, and then select for his 5.0 GXi, and that's where we were. And just look for, like what I did is in here, this is the manual that I had open before. I just do Control F, and then I've put fuel pump, right? That's a search. And then in here, since this is a very broad search, because I mean it's got to be so many of fuel pumps related searches, I just click on that and I just go and clicking on next, next until I see something that actually brings my attention. Because any related text that shows fuel pump is going to be shown in here. So I did exactly as you said. I'm just clicking next and next and next because it's 184 search results. And then I click into the one it shows me. It's in page 61. We will see, but it's page 61, and this had like section 1, 2, and so on. All right, so this is well, it's also shown on TBI diagnosis page 110, and then I just zoom in, and this is exactly where we were. So I'm trying to show you where you can find your information if you have Diacom. All right, going back to the test. All right, so we got good communication. The computer has no issues communicating. I have, again, no warnings, no codes, and that was the same thing when I had the computer in here. I always save the first history to see if there's any history fault code. It was nothing in there. So I'm going to turn the computer off. You're going to see the fuel pump is going to go off, and now it did. I can also, with Diacom, go into test. And this is something you can do, Thomas, if you have Diacom or a diagnostic that is capable to do this. Just doing ACM output test, fuel pump. You see how that puts a red dot in there? This is going to just briefly do like the 2-second test. And let's see that result. So I'm going to press that button and just focus onto that, right here. I just made that because this is, relays that I can use into my simulator, but I name it there fuel pump. All right, so I'm going to click it now. You see it's activating it, And I can do this as many times as I want because it's an output test. All right, so the next thing that I want to do, since I'm always, a data analytic person, I want to put an oscilloscope channel to here, and we're going to see what is exactly or how much is the computer pulling down on that relay driver. Because I can see activations in here, and I'm not saying that, that anything that he did is wrong, but realistically for the light that I can see and the brightness, and because this has actually relays inside the simulator, I know it's being pulled. And I have used this always, and I have never had a problem with that. So we're just going to see the yellow channels are going to turn the rest of the channels. So now we only have channel B, sorry, channel D, which is the yellow. Right now, with the computer off or the fuel pump not being pulled, we got 11.96 volts. So this is what that is supplying through, the simulator. So I'm going to get Diacom in here. I'm going to make this a small on one side and then have the oscilloscope on the other side. And we're going to see the fuel pump again. I didn't see it. Is it running? We're in the yellow. Oh yeah, 5 milliseconds per division. That is too fast. Because remember, this is a 1 second activation. So yeah, if you have a 5 millisecond, you will never see it, right? Because it's just too fast for what we're seeing. So let me start a capture, and we're going to, pull it. Now we can see that. I'm going to do it a couple of times, and we can see how it's pulling it from, from battery voltage to, let's see. Now we can put another cursor here, and we can see, it's around zero point 0.6 of a volt, normal for relays. I don't see any problems on that. And now the next test that I'm going to do, just to even stress it even further, right? So I'm going to unplug that I have here. I'm going to put now a load, even a bigger load, which is going to be a test light. So it's still connected to that same relay. Let's do an activation one more time. I'm going to run the oscilloscope and do the same test as here. Yeah, it's not enough to light up a bulb with the because it's being pulled. Let me actually do this differently because we're not really providing at 12 volts. All right, so let's now connect it to 12 volts because that's through a relay. And now you can see when I do that, now my battery voltage, this is a more like in the boat. Now we got 13.13. Now I'm not going through the relay internally. I'm just going through a test light. So let's see what this is going to do. And you see, it's being pulled. Very good. So we can light up a light. You see what I mean? If this can light up a light, it has enough to put a relay, no doubt about it. And we can see the activation in there. Yeah, with a test light, since it's not a relay, we got like a 1 volt drop, or from 13.13 to 1 volt. And the reason of that is because this is not a relay, right? So if this will be the exactly relay that you have in the boat, it will probably pull it down. And this is what I see usually on relays, half a volt, from whatever battery voltage to half a volt, and that is considered normal due to the circuitry inside the relay. But I don't have any problems with the fuel pump. So now I'm going to run the computer. We're going to connect it again. I'm going to run the capture. We're going to see now, yeah, the voltage drop to down the relay voltage that this simulator is providing. Again, this is on the simulator, right? And we're going to run this. We're going to see the line coming on, and we can see how it's now being pulled. You see the difference of the voltage drop when it's connected to our relay. Right now, we're like in a zero point 0.5, zero point 0.6. Again, I'm not, too zoom in or even filtering the signal to really see what the line is doing. But I guarantee that if I pull this or clean it more, it will be around half a volt. So now I created a trouble code. Probably I didn't like. You see right now we got a trouble code. Okay, this is actually good because I want to show you this. So since I connected that test line, the computer didn't like the load that we put onto that driver because it's not meant to be that. So now we got trouble codes 1, and if I see a star without malfunctions, now 0. You see what I mean? 0 star without malfunction. So if we go over to codes, pump, low, open. So it actually didn't like that I unplugged the relay. It was not because of the light, actually because I unplugged it. So I released it to plug my light, and now it's not going. We're not seeing that 12 volts coming down on the wire going to the computer. The computer knows it has a fuel pump open. So I have erased the whole code. I'm going to now turn the computer off. We're going to lose the communication. You're going to see the bar coming in there. I'm going to turn it back on, and we're going to run it. In like a 2-3 seconds, it's going to show start with malfunctions 1. It always adds up every single time you start a computer, and it has no problem. So all the drivers you see right now went to start without malfunctions 1, and we have a start without warnings 255 times. That's the maximum number. So it has not detected 255 starts up a problem in warnings or anything. So yeah, Thomas or Tom, yeah, Thomas. I don't see any problems whatsoever with your computer. I hope that you guys like the content. I'm trying not just to, oh yeah, the computer is good, send it back to the customer. No, I'm trying to take the time, show 'em what kind of tests you can do on the boat. The test light is a very easy, bright, visual signal that you can use for do all the tests that you always want to do in a boat. And I'm doing the voltage drop, and I start to use my multimeter. I use my oscilloscope. So it's the same thing. You can use your multimeter, connect it in the same way, and you will see what the voltage drop is when you're doing the activation. But yeah, nothing wrong with this computer. I'm going to, run it in high, but his problem is no fuel pump activation. So I'm right now like around 3,000 RPMs. I'm going to change the throttle value around 25%, and everything is working good in there. So you can see now, like I said, I can do this, and I can do throttle position. So the rest is very hard for you guys to see from the distance. This is easier to see on the icon. Sorry. But yeah, again, I don't see anything wrong with the computer. Injectors, milliseconds are good, nice and steady, clean signals. I got the activation for the coil. This is a one EST driver. It's a 5.0, so nothing wrong. All right, Thomas. Again, I'm trying to over stress test and everything you can do in there, where to find your information, but this is as much as I can do for you. And all guys that are watching the video, thank you so much for visiting the channel. Don't forget to subscribe. See you next time. Bye bye.